Good afternoon. In this overview, we will be discussing the low voltage field wiring and the setup of the TLE furnace product with a typical two-stage outdoor unit. In addition, this overview will be for 24-volt conventional wiring only because the TLE product is a non-communicating furnace. At this time, please follow along as we discuss some of these key topics. Low voltage thermostat wiring, including jumper selection, motor speed tap selections, and layout of the ultra low NOx control board. We're also going to talk about motor speed selections to provide 65% cooling airflow on a Y1 call, and then a field fabrication of a Y2 ECM motor tap to provide 100% airflow for a two-stage cooling call with a two-stage outdoor unit. So this is very, very interesting. This low NOx furnace, even though, team, it's a single-stage low NOx furnace, single-stage gas heating only furnace, it does have an ECM motor in it, and we're going to discuss how we can actually apply this with a two-stage outdoor unit. Now, it should be noted that this furnace is probably one of the most versatile furnaces we have in our inventory, in the fact it will actually match up with any of our outdoor products, any of our champion outdoor products, with the exception of the fully communicating only HL 20 and the AL 21 products. So the very, very high-end 20 and 21 SEER products it will not match up with. However, everything else it'll match up with in our inventory. So a very, very versatile product. It's a great furnace. So the first thing we'd like to do today is to go ahead and go over the ultra low NOx control board layout. And again, this control board will be found in both the TL8 and 9E product, the ultra low NOx product. So starting at the bottom of the board, we see this is where we're going to have our 24-volt thermostat hookup. It's very, very conventional. Y is going to be your cooling call. W will be your heating call. R is 24-volt hot. That's very conventional. G will be your fan call. And C is your 24-volt common. Now, it should be noted that 24-volt common is typically going to be a blue wire from the thermostat. It should also be noted that on our furnace product, we always take one side of the transformer and we take it to chassis ground. So one side of the 24-volt transformer, we take to chassis ground, and we call that common. So from a technical standpoint and from an electrical standpoint, please remember that 24-volt common, this C terminal, 24-volt common, is actually referenced to chassis ground. As we move along the bottom of the board, we see we have a model ID plug. Now, team, please remember, if you have a replacement board, you have to take the model ID plug off the original board or off the old board and put it onto the new board. And as soon as you power the new board up with the model ID plug, it knows what furnace it's hooked up to. So please remember to remove the model ID plug off the old board and snap it onto the new board if you have a replacement board. Feature on the board is a heating off delay. We see we have an ABCD function on the heating off delay. What this field selectable jumper does, it allows the technician to set up our heating off delay. In other words, once the once the call for heat goes away and the thermostat is satisfied, the fan continues to run to distribute that residual heat on the heat exchanger into the conditioned space. And there's 4 selections, A, B, C, and D. Now, typically, we will ship it from the factory on C. Now, please write this down. A is 60 seconds, B is 90 seconds, C is 120 seconds, and D is 180 seconds. So this is very, very typical. I think we have one model of a furnace that maybe has a little different timing, but a very, very typical timing will be 60, 90, 120, and 180 second heating off delay. Right next to the heating off delay jumper selection is a field selectable jumper for cooling on delay. Now, team, what this does, it prevents the indoor fan from coming on for a few seconds to let that evaporator get nice and cold before it brings the fan on. So this cooling on delay is actually a nice comfort feature and a dehumidification feature on our champion control board here. So from the factory, it comes from the cool on delay jumper in the A position. And please write this down. The A position is 6 seconds and the B position is 24 seconds. So again, if you have kind of a humid environment, you can move that cool on delay down to the B position, and that will delay the indoor coil, or excuse me, the indoor fan from coming on for 24 seconds in the B selection. For 24 seconds, it'll delay the fan coming on, and so the outdoor unit will come on. It'll pre-chill the evaporator coil to allow better dehumidification every time you have a cooling call. So this is a nice little dehumidification function that you can manipulate in the field. A is 6 seconds, B is 24 seconds on our cooling on delay. Right next to the cooling on delay jumper, we have a SW1 fault recall switch. And what this does, it allows the technician to recall any faults on the board. So by depressing the fault recall switch, he'll be able to pull flash codes off the board in its memory. Now, it should be noted it remembers the board remembers the last 5 faults. After the 5th fault, it kind of rolls off the end. In other words, so it's going to remember just the last 5 current faults. In addition, if you hold the SW1 switch down, if you hold the fault recall switch down for about 10 seconds, it clears the memory. And we recommend the technician does that. And as a matter of fact, if he's out on a service call and he looks at it and he repairs the furnace, or he has a repair, once he repairs that furnace, we always like to have him clear that memory on the fault recall. That way it'll have only fresh fault codes in there if there are any more fault codes. So again, to reset that button or to reset that fault memory, hold that button down for about 10 seconds. As we come around the board, we see we've got a 3-pin PWM for the inducer motor. Now what this is, team, remember, it's a pulse width modulation. So here's how this works. The inducer motor is a high efficiency type of motor, and so it has power to it all the time. But hang on a second, it's just sitting there waiting for a command, a 24-volt command. Well, that's what this 3-pin PWM jumper is for. What it does, it'll actually put a pulse width modulation, which is just a DC voltage, to that inducer draft motor to tell it what to do. So again, this high efficiency motor on the induced draft motor it'll have power to it all the time, and then it's going to be commanded on what to do with this 3-pin pulse width signal, which is a DC voltage signal to command the motor. Right next to that, we have a 4-pin 120-volt inducer motor and igniter harness. And so again, team, I want to stress, the 120-volt AC is going to be provided to the induced draft blower all the time, and then we'll send it a DC signal to tell it what to do and how fast to run. In addition, during ignition sequence, we're going to put 120 volt on the igniter on this 4-pin harness to heat that up. Now, please write this down. Typical igniter warm-up is going to be about 17 seconds. If you fail to ignite after 17 seconds on a trial run, it starts adding some time to it. And typically it'll add about 1 or 2 seconds until it has a successful ignition, up to, I believe, 25 seconds. So it starts out at 17 seconds, and then if you have successful ignition, it'll just remember that and continue to have 17 seconds from then on. Right up next to the 4-pin plug, we see we've got 5 neutral connections. Those 5 neutral connections will have the white wires from the different components on there. So this is 120 volt neutral connections, and there's 5 of them as you take a look at the board. Right next to the neutral bus, we see that we have a 120 volt input to the board. Now this is where the power comes into the board to drive the 120 volt components. So from our power source, we'll go through from our power source feeding the furnace, we'll go, I believe it's a black wire, they'll plug right on to line, and that line is the 120 volt input to the board. Right next to that, we have our 120 volt output to our ECM motor. Now, team, remember something about ECM motors. The ECM motor is a high efficiency motor. And by the way, that ECM means electronically commutated motor. That's just a fancy name for a high efficiency motor. Now, it should be noted, all ECM motors have power to them all the time. So anytime the furnace is powered up, you've got power to that ECM motor. Now watch this, the motor's just sitting there waiting for 24 volt commands to tell it what to do. And so a little bit later on, we're going to be discussing the fan speed and the heating speed and so on, but those are all 24 volt commands. So please remember, from a safety standpoint, even though the blower is not running on the furnace, that motor is powered up all the time. As a matter of fact, from a safety standpoint, we're going to ask that if you want to work on that motor, or if you want to pull that housing off the back of the motor, shut the furnace down, make sure the power is off, and let it set at least 10 minutes to allow any capacitors that are inside that motor bell housing to discharge before you handle that motor. So from a safety standpoint, please give it a little bit of time to bleed that voltage down once you remove the power. So again, 120 volt output to the ECM motor all the time on the motor terminal that we're looking at right now on the PowerPoint. Next to that, we have our 120 volt output to the transformer. That's the XFMR circuit, and the XFMR is 120 volt output to the transformer anytime there's power on the furnace. The next terminal is a HUME terminal. It's 120 volt output for a humidifier. Now, it should be noted, you'll notice there's a little black insulator on there. Well, that's easily removable if you want to utilize this 120 volt output for a humidifier. Now, team, please make a note of this. This HUME terminal, this 120 volt output humidifier terminal, will be energized anytime you have a call for heating. Anytime you have a heating call on the board, that will be energized if you want to utilize a humidifier on a heating call. The next terminal is an EAC terminal. That electronic air cleaner terminal is what EAC stands for, electronic air cleaner. It's a 120 volt output. You'll also notice there's a little black insulator on there for safety. And again, just remove that little black insulator and hook up your 120 volt output for an electronic air cleaner. Now, please make a note of this. Anytime the fan is running, this electronic air cleaner output will be energized for electronic air cleaner. This is our 120 volt flame sensor terminal. Now, team, please remember this as well. Anytime the furnace has power to it, the flame sensor will be active. And so the flame sensor by National Gas Code has got to be active all the time, year round. So anytime there's power on the furnace, you'll have 120 volt flame sensor terminal will be energized. Now, please note the flame sensor, even though it has 120 volt on it, it's an extremely high resistance circuit. So if the sensor probe should touch the ground, or if a technician should touch it during his diagnostic procedures, it's not going to shock them, because it's a very, very, very high resistance circuit, but it is line voltage driven. So please be aware that the flame sensor terminal is 120 volt output for the flame sensor. As we move over to the upper right-hand corner of the board, we see we have a ground terminal. This is a ground terminal. It should be noted this ground terminal will be referenced to chassis ground. So it's a separate ground terminal on the board to ensure that we have a really good ground on the board. Now, please remember this. You have to have a good solid ground in order for the flame sensor to work properly. As a matter of fact, the #1 cause of low flame current, or a problem with the flame sensor, is poor grounding. So please remember that. It's very, very important. This board has to be grounded, and it has to have a good, clean, solid ground all the way back to the power panel for the furnace to work properly. As we move down the right-hand side of the board, we see there's a 24 volt fan terminal. Now, team, this 24 volt fan terminal is an isolated terminal that allows continuous fan operation if the homeowner or the building owner goes to the thermostat sub-base assembly and switches the fan from auto to on. Now, remember, this would be without any other cooling call or heating call or any call on the board, just a fan call only. This fan terminal will be energized when you have a G call on the board all by itself. In addition, from the factory, we typically ship this fan terminal on the low speed of the fan. And the reason we do that is that then allows a nice low continuous fan speed that's going to be nice and quiet. And it's also going to allow that continuous fan will allow the homeowner to utilize any of their clean air products. So if they have an electronic air cleaner or a media type of air filter or other air cleaning devices or air purification devices, they can now circulate the fan continuously with just a G only call on a low speed. This is our heating terminal. This is where we're going to select from this terminal when we have a heating call for operation. What speed the indoor blower runs on the heating mode of operation will be determined by this speed tap. So again, the wire that it's on is typically on medium high from the factory, but based on the ductwork and based on the amount of airflow that's required and so on, the technician in the field can manipulate which speed tap on the motor is going to be utilized for the heating speed. This is our cooling tap. This is our cool tap. Now, it should be noted, this cool tap will be energized on the cooling airflow on our unit. Now, when we start talking about a two-stage hookup, please remember this cool speed will actually have to be selected on a speed tap to provide 65% airflow on a Y1 or first stage call on a two-stage cooling unit. But we'll discuss that a little bit later on. So just know that from the factory, we typically ship this on high speed, but you can manipulate that cooling airflow with this cool jumper or this cool terminal for a two-stage product as well. Now, please make a note of this, team. If you haven't got this written down, please make a note of this. We always encourage you to make sure that your airflow is correct. The airflow should be 400 CFM per ton of cooling. So in other words, if I have a 2-ton unit outside, I'm going to need 800 total CFM on a 2-ton unit. If I have a 3-ton unit outside, I'm going to need 1,200 CFM and so on. So we always want to design our ductwork, and we always want to commission our furnace to make sure that in the cooling mode of operation, we provide 100% airflow on a single stage unit, 65% airflow on the first stage of a two-stage unit, and then 100% airflow on the second stage of a two-stage unit. And again, we're going to manipulate our cooling airflow based on our, if it's a single stage or a two-stage unit. But please remember, 400 CFM of cooling on high speed or on second stage if it's a two-stage unit. And if it's a single stage unit, 400 CFM per ton is going to be the nominal airflow that we want to always set up our ductwork and make sure that we have proper airflow whenever we set our furnace up. So again, this cooling tap will be energized anytime you have a Y call to the board, and again, we're going to manipulate this cool tap for 65% airflow when we start talking about a two-stage product and our Y1 airflow. Here we have a 24-volt common to the motor. And again, team, remember, on an ECM motor, you have power to it all the time, and you're going to tell that motor what to do with 24-volt outputs from this board and the thermostat to tell the motor what to do. So there's the 24-volt common to the motor. Here we have two park terminals, two motor park terminals. These park terminals are designed for nothing more than to put unused motor taps or unused motor wires, speed wires, on the board. So instead of just taping them off, we give you a nice convenient place to put them on these park terminals. It should be noted the park terminals are just blank terminals, or just a convenient place to put the unused motor speed taps. Here we have our 12-pin harness. Now remember, team, the 12-pin harness is where you're going to harness in from the factory for those critical components like rollout switches, pressure switches, high temperature limits, the gas valve. Those are all components that are going to be harnessed into the 12-pin harness. So these are 24-volt inputs and outputs for safety circuits, pressure switches, gas valves, etc. Here we have a 3-amp 24-volt fuse, and this 3-amp fuse provides onboard protection for all the 24-volt circuits on the board. Team, please remember this diagnostic LED that we see at the bottom of the screen here. Please remember this diagnostic LED is a tricolor LED. And so you'll notice that when there's no power to the board, it's just kind of a milky white colored, but it should be noted that this LED will flash either red, green, or amber, based on the flash code. And you can always look at your install information and the service information to retrieve those flash codes. So this tricolor LED is designed to flash red, green, or amber based on the flash code on the board. Okay, at this time, let's go ahead and talk about just a real simplified block diagram to hook up a 2-stage cool, 1-stage heat, 24-volt thermostat with our TL9/8E ultra low NOx furnace and a 2-stage outdoor unit. Now, it should be noted this 2-stage outdoor unit, the first stage of cooling on this 2-stage unit will be 67% capacity. So when we hook this up, we're going to have to make sure that our Y1 call from the thermostat and the Y1 call outside, which is first stage compressor operation, it's going to be 67% capacity on the outdoor unit. So please note that when we set this up, we're going to have to select a speed tap on our cool terminal with a Y call on the furnace, and we're going to have to select a speed tap on the motor to give us 60 to 65% airflow on a Y1 call. And then when we select Y2, we'll show you some unique things that we have to do to wire this in order to have our Y2 output and our Y2 call from the outdoor unit back to the indoor unit. So it's very, very straightforward, but let's go ahead and look at this very, very simplified block diagram. So the first thing we'd like to point out, just like any other thermostat, common, C from the thermostat to the indoor unit and then to the outdoor unit. That's typically a blue wire, and it just goes from one to the other outside. R terminal, which is 24-volt hot, from the thermostat to the indoor unit to the outdoor unit. And again, most contractors use just a red wire to remind them that's their 24-volt hot. Now, as we start taking a look at our fan call, it should be noted G is our fan call, and it may be used for continuous fan operation without a cooling call from the thermostat. And so remember, team, if the homeowner goes over to the thermostat subbase assembly and they go from auto to on the fan, it's going to generate a 24-volt signal on the G terminal. And so that fan call, we can use that as a continuous fan operation without a cooling call from the thermostat. And so this is a very, very nice feature on our Champion control board here that allows us to circulate air at a very, very low RPM or a low motor speed. And it allows, wonderful filtration across the clean air devices, electronic air cleaners, immediate air cleaners. And so a lot of homeowners like to do that. Now on the board itself, the fan terminal on the board itself is typically going to be hooked up to a low speed tap on the ECM motor. And so this is a very, very nice feature for a fan only call and continuous fan operation. So again, we recommend that on the control board where it says fan, go down and select a low speed motor speed tap so that during a call for continuous fan operation, the fan runs at a nice low constant speed, which is very, very quiet. It provides great filtration anytime that fan is running. Even though we're not calling for a cooling call, it still is going to run at a very, very low speed, and it'll just give us some wonderful comfort as well as good filtration. Now, in order to have our cooling call, we're going to connect Y1 from the thermostat, and we're going to connect it to the Y terminal on the furnace and then go straight outside to Y1. So Y1 from the thermostat to Y on the furnace to Y1 outside. Now remember, team, this is going to be our first stage compressor and our first stage cooling call. And so what we're going to do, we're going to go from Y1 to the thermostat to the furnace and select the cool terminal on the board down to the ECM motor speed taps and select the motor speed that's going to provide 60 to 65% airflow on a Y1/Y call. So Y1 call from the thermostat, Y call on the furnace to Y1 outside is our first stage cooling call on a 2-stage product. And the capacity of that 2-stage product on a Y1 call is about 67% capacity. That's why we want to have our airflow inside matching that as close as we can, as close as we can. So be sure and select the motor speed tap to provide 60 to 65% airflow on a Y1 call. Y2 from the thermostat is going to go directly outside. Now, team, watch this. It doesn't even touch the indoor control board at all. So Y2 from the thermostat goes straight outside. Now choose any color you like on that thermostat wire, but typically we find that most contractors on that Y2 or that high-speed cooling call, they're going to typically choose a yellow wire for the high speed. Now, because this is a single-stage heating thermostat and a single-stage heating furnace, we're going to take W from the thermostat and connect it to W on the furnace for our heating call. And again, choose any color you like, but typically we find that most contractors will use like a white wire for that heating call or that W call. Now, team, please watch this. Outside on the control board, outside on the two-stage unit, there's going to be a Y2 output, a Y2 out. That Y2 out is going to be a field fabricated wire, a field fabricated 24-volt wire, and that Y2 out on the outdoor control is going to come in, and you're going to select a motor speed tap on the ECM motor to give you 100% cooling airflow. And again, select any color you like, but most contractors are going to use that yellow wire outside. So for a Y2 call, you're going to have a terminal outside that says Y2 out. That Y2 out will be a field fabricated wire. We're going to come in and land it on the ECM motor to give us 100% airflow. And so that 100% airflow will come on whenever we have a Y2 output from the outdoor unit. And so really what we're doing, team, we're letting our champion outdoor two-stage unit command second stage airflow inside when it's in second stage cooling. And so that Y2 out from the outdoor unit will come in, and again, we have to field fabricate that wire. It's just 24-volt, low voltage wire. It's just very, very simple. And you just put a spade connector on the end of it on the inside. And so you bring that wire in, put a little spade connector on it, and then attach it to a motor speed tap that gives us 100% airflow. Now, team, remember one more time, we want to make sure that that 100% airflow is 400 CFM per ton. So if I have a 2-ton unit outside, that 100% airflow needs to be 800 CFM and so on. One final note about the ECM motor that you've noticed that, we could have a G call to the motor. We could have a Y1 call to the furnace, and it tells the motor what to do. We could have a Y2 call going to that ECM motor. The point is the ECM motor, one of the great things about the ECM high efficiency motor is if it receives more than one speed command, let's say it has a G call and a Y1 call and a Y2 call, that's perfectly okay. It's not going to hurt the motor. That motor is designed that if it has more than one 24-volt speed command, it always drives that fan to the highest speed that it's receiving. So we call that airflow priority. So that fan motor is actually got 3 speeds. It's actually commanding 3 speeds in this example, G, Y, and Y2, but that's okay because it will always take the highest of those commands and drive the motor to that speed. Okay, this is a recorded session, and if we were doing a normal training session, we'd go ahead and entertain your questions at this point. But because this is a recorded session at this time, we'd like to thank you very much for watching this video and your attendance on this video. And so by all means, please continue to go to your Champion Trainings YouTube channel, and we will be housing more videos out there in the future. But thank you for your time today, and have a great day.